We're ready to proceed with the final two talks of the afternoon. And the first talk will be from Daniel Coker. One of the things that we saw this morning was the relationship between Daphne and other parts of the UCRIC program, particularly urban observatories. So Daniel is going to talk about digital twins and urban observatories, how Daphne is supporting the National Digital Twin Agenda. Over to you, Daniel.
Thank you, Brian, and good afternoon, everyone. In my talk, I aim to highlight, as Brian has mentioned, the key role that Daphne will play in supporting the National Digital Twin Agenda, and show how Daphne, in partnership with urban observatories, has already started developing digital twins of infrastructure systems, assets, and processes. Now, given the focus on digital twins, I will start by introducing briefly the technology, so personal view of the technology and the National Digital Twin Program. I will explain the key role that Daphne and urban observatories play in realizing the ambitions of this program. I will then introduce the Sheffield Urban Observatory and highlight the key elements of the urban digital twin that Daphne should be in a position to host, before providing a brief overview of a Daphne-enabled digital twin pilot for Sheffield traffic, which we developed as part of a 3-month project funded by Daphne. Now, the term digital twin, as many of you know, was proposed in 2003 in relation to product life cycle management. Now, before that, major industry players were already developing and using digital twins, companies like Rolls-Royce, for example. I assemble here a short list of definitions that have been put forward by academics, industry, government, and I've chosen this as they reflect the views of some of our key stakeholders. Now, what all definitions have in common is the fact that at the heart of a digital twin is a computational model, a virtual representation of a process, a system. Now, some explicitly mention the need to maintain this representation up to date so that it mirrors the properties of the physical system throughout its entire life cycle. Now, clearly, trying to capture the essence of what a digital twin is in a few lines is difficult. This is because digital twin is more than just a virtual representation or mathematical model of a physical system of process or a process. Now, as a control system engineer, I like to think of and I think that the digital twin should be seen as a system. It's not, as I said, just a model. It's a system that comprises of high-performance computing platform, a repository for data, model, and also models. And these models make up the virtual representation of the system or process that it's being twinned. The digital twin is also used in combination with analytics, workflows, and decision support tools to assess the consequences of various design choices, to determine optimal actions that maximize key performance metrics, evaluate alternative development, implementation strategies, and forecast the effects of operating and servicing decisions. So for that, you need an analytics and AI level that eventually can actually start making autonomous decisions and in real time. Now, finally, as the digital twin is expected to change dynamically in near real time as the state of the physical object changes, the digital twin has to be connected to the real system, to the real world, in order to acquire and assimilate environmental and operational data, and thus enabling physical infrastructure assets to live a parallel life in the virtual world for their entire life cycle. Now, planning, designing, building, and managing national infrastructure system is complex. is high cost, is high risk enterprise that involves a myriad of stakeholders and partners and requires making very difficult choices, many of which would have consequences that are felt for many decades after. So a radical new approach is to use these vast amounts of data collected from manufacturing, maintenance, operation, operating environments to create digital twins of national infrastructure systems. Now, this is the goal of the National Digital Twin Program, which is led by the Centre for Digital Build Britain in partnership with the Department of Business, Energy and Industrial Strategy. Now, I highlighted here the key objectives of the program: an ecosystem of connected twins, secure and resilient data sharing, coordination among key players, as they map directly on some of the key objectives of Daphne. So in essence, if you look at what Daphne has to offer, Daphne provides the ideal ecosystem to host digital twins. It has the cloud computing environment, it provides secure data sharing, it has a database of data, but also will hold models. It's got a software platform to interconnect and simulate models, deploy advanced analytics and visualization, and more importantly, bring in real-time data to perform the all-important data assimilation and model update. Now, while the real-time data connectivity has not been a top priority at the start, we have made progress on that front, and this especially working with urban observatories. And in my opinion, in the short term, urban observatories are the best place to develop and demonstrate digital twin technology in partnership with Daphne and other stakeholders. And this is because urban observatories are already collecting vast amounts of data in real time. And while observatories have their own data platforms for storing, sharing, and visualizing data, they do not have, and we do not have, the ecosystem to support digital twins. And certainly, we cannot provide the integration of data from across the city, from across UK. So this is why I think the partnership between observatories and Daphne is crucial. And I'm going to illustrate this point by focusing on the partnership between Sheffield Observatory and Daphne. Now, the Sheffield Observatory is so-called the Urban Flows Observatory because the ultimate aim is to understand urban metabolism. Now, this means understanding the flows and processes, and to that, at the urban level. To that end, we deploy the comprehensive range of fixed and mobile sensor platforms that is still evolving, and which provides the data needed for us to start building a digital twin of urban metabolism. So we have weather stations, air quality sensors, we measure traffic, energy monitoring. We have a number of mobile sensing platforms that are equipped with a range of sensors that allow us to map, for example, thermal efficiency of the building stock. Now, as I said earlier, we have developed, like other observatories, our own platform for data storage and visualization. However, we do not have the capability to integrate and scale the data with modeling, simulation, and analytics. So to achieve that, we certainly need a platform that enables us to implement the computational workflows and the algorithms that turn raw data into actionable insights and then ultimately into decisions. So I mapped here, I've highlighted just a few of the key computational steps in the workflow that will be needed to be implemented in order to make an urban digital twin a reality. So we have data curation, missing data recovery and fusion, so basically dealing with the issues that not all the sensors are working properly at any one time, and then using this data to provide some quick real-time data analytics, basic statistical analysis to understand what's going on. However, this data, the best way to use this data is to turn it into models, in models that can later be updated. So we have a data assimilation functionality that will need to be implemented so that continuously the model is updated at a regular intervals, so that the model then it keeps mirroring the real process. And then the models can be used to do urban metabolism assessment and ultimately implement or support model-based decisions and policy decisions. Now, as part of a project I mentioned earlier, which was funded by Daphne, we started to put in place the foundations for a digital twin of Sheffield traffic. It's by no far completed work, but I'm just highlighting what we've done so far in this respect. So in Sheffield, we have access to around 640 sensors that report traffic flow. And this is measured with a resolution of 5 minutes. On the right, you see a map of the location of the sensor, but these are not individual sensors. Rather, you can see that each circle has a number attached to it, so that shows the number of traffic sensors that are deployed in that area. So if you zoom in, you will get full details on where the sensors are located. Now, what was interesting for us and what we needed is a platform that provides the computational power to perform the machine learning inference for all the traffic sensors in real time. So initially we developed offline a model in MATLAB, and these are actually a number of models that we developed and evaluated. You can see there the key modeling steps. So this was done using historical data. We had quite a bit of that. So we trained and evaluated a number of machine learning models for traffic forecasting. However, the acid test for Daphne platform was when we had to deploy our MATLAB-based model in Daphne. And the diagram on the right shows the key implementation steps. Now, because Daphne does not have a MATLAB license, we had to containerize the MATLAB runtime libraries, and we have to then make it work in Daphne within the container so we can run our MATLAB code. Obviously, the heavy lifting was done by the Daphne team. Now, the key message is that we were able to successfully deploy and run our MATLAB models in Daphne. We also implemented a basic visualization of the results. So here are a few results illustrating the forecasting performance of the model and the basic visualization we have created. Now, the point of this is not to say that we have now a digital twin of traffic. We just want to demonstrate the feasibility of deploying the technology. I think there is a lot more work to do, improving the model and also realizing the update in real time of this model with the data coming from Sheffield. So this is what I had to present, and the conclusions I want to draw attention to are this. Basically, Daphne is a unique key technology platform that will enable the development of digital twins of national infrastructure systems. Now, the sheer scale of the challenge will clearly require multidisciplinary research effort and a significant investment over many years. And in the short term, my belief is that urban observatories are best placed to develop and demonstrate the digital twin technology in partnership with Daphne and other stakeholders. So this is all from me today. Thank you very much for your attention.